Good morning, students. Welcome to the class of Technomathematics. So today we are taking some concepts and question based upon the basic proportionality theorem and applications. Okay. So what is basic proportionality theorem that we need to understand, right? For any triangle, for any given triangle. Okay. Let us say any triangle is given to you, right? And into this triangle, if a line is drawn parallel to the any of the side, let us say this is the third side and this triangle is ABC, right? Let us say this line EF is drawn parallel to the third side. Okay, let me zoom a little. If this is parallel to the third side, right? Parallel to the third side. If this is the first side, second and side, and this is the third side, then definitely, then the parallel side which will be intersecting the other two sides at two different points E and F, right? Then it will be given that it can be said that it divides the other two sides, that means this side and this side, into the same ratio, right? That means here we can say that whatever be the ratio of, if E, let me write the condition first, EF parallel to BC, right? If EF is parallel to BC, right, then the ratio of this section AE here, right, this AE would be AE to EB, this ratio, right, AE to EB will be equal to AF by FC, right? I mean to say the ratio of this AE to EB is equal to the ratio of AF to FC, right? This ratio. This this is the theorem. Okay. This is also known as Thales theorem, my dear friends. Okay. We can also see that the converse of this is also true. That means if a triangle is given to you, okay, and this condition is given, that yes, the ratio the ratio of maybe 2 points E and F are here, right? And it's not given that EF is parallel to the third side, right? It's not given, but it's given that AE by EB is equal to AF by FC. Then into this condition, the converse will be valid. That means if this ratio is said to be happening, that means AE by EB equal to AF by FC over here, then we can say that yes, definitely EF is parallel to BC, right? This EF is parallel to BC. Is this EF will be parallel to BC. So my dear friends, two things we have discussed, okay? If it is given parallel to, if a line is given parallel to the third side of the triangle, then the ratios will be the same, okay? Ratio of the point of intersection on the two sides. Here it's E and F, so there, that's why AE by EB will be equal to AF by FC. And into the converse, if the ratio is given as equal, then we can say that yes, these lines are parallel, right? These are the main. First thing, the Thales. Second one, we see the reverse of that. We'll see the applications, but what are the main things from the triangle that we need to see? Okay. The third thing which we need to capture over here, the third theorem over here, is that if a triangle is given to you, right, let us say ABC, right, and here is a point D lying over here on the BC, right? Into this case, what will happen? And AD will be the line joining and intersecting BC at D. And it's given that BD by DC is equal to AB by AC. You know what I said? The line coming from the vertex A, right, is intersecting BC at D, and it's given that BD by DC or CD, you can say, is equal to AB by AC, right? Into this condition, if this condition is given to you, then that means this line AD bisects the angle from the bisects the line which is coming from the vertex, bisects the angle. That means this AD is initiating from A and going towards D. So then A is the vertex, then this angle, right, this angle A will be bisected if this condition is valid, right? So in this case, we can say that if this is angle 1, this is angle 2, if this condition is valid, this implies angle 1 equal to angle 2, where angle 1 plus angle 2 is nothing but angle A, right? I'm saying for A. I hope it's understandable, right? So this theorem will be valid. Now the next theorem, okay, we'll be seeing the applications of this. So we are quickly revising what are the basic theorems which need to be taken care, right? After this, what is the next? Let me filter. If you want me, I can quickly take up few questions. Okay, let us say a triangle is given to you, okay, here like this, and it's given that this line is parallel to EF is parallel to ABC. EF is parallel to BC. So into this case, what will happen? If so, here definitely length of this is given to you, okay, and maybe length of this is given to you, and even this one. So I mean to say that if AE by EB is given to you as equal to AF by FC, because EF is parallel to BC, then definitely Thales theorem will be valid. And into this case, if this ratio is coming as, it can be taken as equal, right? And if these three values are given to you, maybe AE, AF and FC, and one of the value is not known to you, right, then these questions can be solved very easily using the Thales theorem. Okay, it may be given that yes, this is, suppose say this is x, this is given as x plus 2, this is given as x minus 1, right? Then we can easily find EB. How? X by EB is equal to x plus 2 divided by x minus 1, like that, right? So it will be, or not x, maybe the values will be there, and even if the EB is given into the form of some x, right, let us say 2x, right, then you can simply solve it and find out the value of x, and then the corresponding values of the AE, EB, AF and FC. It can be also given that the instead of x some values will be given to you and one of this is not known to you, then you can easily calculate it by just putting up the values, my dear friends. Okay, so these questions can come to you. Okay, let me take another question. That yes, uh, mm, mm, So find the value of x. This x related code, one of the variable is given, that's we have taken. Values we have given to you, and one of the values is unknown to you. Then that side can be calculated. We have seen two such questions. Now taking up any third question. In the figure, right? In the figure we have taken this. So it can be also given that, my dear friends, that yes, let us say this is a diagram to you. Okay, let us say this diagram to you. Okay, into this diagram, it's A, B, C and D, right? From here, if it's given that maybe this point, this figure is like this. Okay, and if it's given that this is parallel to this, I mean to say, let us say PQR. If it's given that PQ parallel to BC and RQ parallel to RQ, this one is parallel to CD, right? Then into this case, as we have seen, if you consider this triangle, right, then AP by PB equal to AQ by QC, right? We can write AP by PB is equal to AQ by QC, which is equal to AR by RD, right? So it can be given that if this, you need to prove AP by PB is equal to AR by RD. This such type of questions can come into the 2 number. Okay, 2 marks questions. Okay, where you can simply use the, you can see the triangles which are lying. Okay, first the triangle is ABC, then ADC, then you need to correlate the things using the basic proportionality theorem. We have seen the ratios are same, right? So for this triangle we can see that yes, AP by PB is equal to AQ by QC from this triangle. Similarly, from second triangle we can write this one. So that's why if A equal to B equal to C, then A is equal to C, right? Such things can be shown and proved, right? It can be also given that, in this such type of proof can be shown. It need to be also, suppose it's AB, AP and AR, right? These are added with PB and RD, then it can be also written as AP by AB, right? AP by AB is this one entire length, right? Is equal to AR by, AD. Okay, just simply add into both sides and you can see it will be done, right? So such questions can come. If you want me to take more, there is an example which is in front of us from NCERT. Okay, a point X inside a triangle DEF, right? Let me change. So we can use this. Okay, so the fourth theorem which we are going to discuss for today is that the fourth theorem from the triangles, okay, is that if a line, right, if a line is crossing, if a line, if in a triangle, if this is the median of the triangle, okay, if this is the median of the triangle, that means if AD is the median of the triangle, right, then into this case, if two sides of a If two sides and a median bisecting one of these sides of a triangle are respectively proportional to the two sides and the corresponding median of another triangle, then the triangles are similar, right? I mean to say that if these triangles, okay, in this triangle, if D is the intersecting point from of the line starting from A, then and AD is the median of this triangle, right? Then we can say that yes, into this case, the respective sides are proportional. That means BD and DC are proportional to each other, right? Corresponding median of another triangle, then the triangles are similar. I mean to say that if this triangle is given to you and another triangle is also given to you, okay, and it's given that the ratio of the, and if this, let us say PQR is another triangle and PS is the median, PS is also the median of the another triangle, right? Then in this case, right, if two sides and median bisecting one of these sides of a triangle are respectively proportional, that means the ratio of AD by PS is proportional, right? This is the ratio of the medians, right? This is proportional to the two sides and the corresponding median of another triangle, right? So, if this is proportional to these two sides, then definitely we can say that these two triangles will be similar, like that, okay? So, even this will happen for the altitude also. Similarity can be proved, right? So students, we can take further questions from BPT, that yes, let us say a triangle is there with you, okay, ABC. Into this question, what we can see, that yes, if this is 6, this is 4, this is 3, right? And if AD is the angle bisector, right? If AD is the angle bisector, right? Then if given that AD is angle bisector, then into this case we can say that AB to AC should be equal to this one, BD to DC. BD to DC, this ratio will be equal. We have seen this theorem, right? So just put up the values, okay? Now AB is, let us see, write the value 6. AC is nothing, this need to be calculated, this will be acting as a variable, and BD will be 4 and CD will be 3. So here by just simple calculation we can calculate the value of AC, right? And that will be coming as 6 into 3 or 3 into 6 by 4, right? We just did the cross multiplication. So 18 by 4. So this will be coming something like 4, 4.5. So we can solve such questions, students, right? If you want to take me more, there can be a question maybe, okay, which I have taken, and it's given that a triangle is there, okay. This is the angle bisector. The length of this is given to you as, let us say, 10, and this is 14, and this is x, and this is something 2 minus x, right? Then into such questions we know that if angle A is bisected and AD is the angle bisector, if this is given to you, then simply use AB by AC will be equal to BD by CD, right? Just put over the values over here. It will be 10 divided by AC. AC will be 14 is equal to BD is X, and this is 2 minus X. Just solve and get the value of X, and then you can put the value to calculate the lengths of BD and CD, right? So such things can be shown. If you want to take me more, right? You can see the questions, my dear friends. Okay, you can solve many questions on it. Similarly, you jump into the similarity also, right? So these are the basic applications of the basic proportionality theorem, right? If a quadrilateral is given to you, some angle bisectors, okay. There was only one good question which I am looking for to explain you. Yes. If the diagonal of a quadrilateral divide each other proportionally, then it is a trapezium, right? This theorem, you will see. If a diagonal of a trapezium, if a diagonal of a quadrilateral, let us say any quadrilateral is there, right? Let us say, I'm just making it in a shape of trapezium, but don't mind. If a trapezium is, if a quadrilateral is there, whose diagonals are intersecting each other proportionally, right? Then it is a trapezium, right? A, B, C, D is a quadrilateral, right? To prove it's a this this quadrilateral is a trapezium, right? If this is given to you, that means, let us say if this is O, if this is given to you as AO by CO is equal to BO by DO, right? Then you need to prove that this is a trapezium, right? My dear friends, in this question, simply take one of the triangle. Let us take this triangle, which is forming with from one side as a diagonal is the edge. Then you can draw a parallel line from O, right? You can draw. If this is this by this, right? If it's given that it is given that a quadrilateral is bisecting each other, that means ratio of this to this, AO by CO is equal to BO by DO, right? Now into this case, we have a diagonal of a quadrilateral divide each other proportionally, then it is a trapezium, right? So into this question we need to see that if we have given that this is drawn, we have did the construction, we drawn OE, right? OE parallel to CD, do the construction. If OE is parallel to CD, then the ratio of AE by ED will be equal to AO by CO, isn't it? AO by CO, this one will be equal to AE by ED by basic proportionality theorem, BPT, right? Let us say is equal to AE by, into the same sequence as we have written CO, just write DE, AE by DE, right? And since this is parallel to the third side, let us extend it, right? Let us extend it, or you can leave it this part, you can leave this part. If AO and AO by CO is equal to AE by DE, right? Then again into this triangle, which triangle? This one, ABD. In triangle ABD, we can see the ratio of AE by DE This one, AE by DE, because for the triangle ABD, for this triangle ABD, I'm considering this one, right? Into this triangle ABD, what will happen? This ratio AE by DE will be equal to BO by DO, isn't it? Is equal to BO by DO, right? So we can see that if we have considered OE parallel to CD, we did this construction, then this is proved. That is by equation 1 and equation 2. Can't we write that AO by CO is equal to AE by DE is equal to BO by DO? Using these two equations, can't we write it? Just remove AE by DE. Then we can write AO by CO is equal to BO by DO, right? And this is proved only into the case that we did this construction OE parallel to CD. Then definitely OE is parallel to CD and AB is parallel to CD, and it is proved as a trapezium. Okay. So such proofs can be seen, my dear friends. Okay. Any line parallel to the parallel sides of a trapezium divides the non-parallel sides proportionality, that we have seen. Okay. So you can solve many questions, more questions, my dear friends. Okay. We can see if there is any doubt. So if you want me to take any question on this, we can take it up like this. Let us say a trapezium is given to you and whose diagonals are bisecting or intersecting each other, and let us say this value A, B, C, D, right? Then from here, using BPT, we need not to do this construction again and again. We simply say that AO by CO will be equal to BO by DO. Suppose AO is given as X, CO is given as X plus 1, right? So just write X by X plus 1, and BO is given as maybe 2X, and this is 2X minus 3. So just write BO instead of BO, write 2X, this value, and instead of DO, just write 2X minus 3. And just solve it, you will get the value of X and correspondingly. Such questions can come. Okay. So, my dear friends, we can solve this. Okay. I'm just referring one of the few questions which are available to me. Now that's fine. I think you can to the triangle playlist into my channel. You can see multiple questions based upon this. Okay, you can go through these questions because in a session it's very difficult to cover entire book or entire chapter with all the questions, right? So you can go through the playlist and you will see many questions based upon basic proportionality, and into the triangle I have collected around 92 questions. Okay, you can go through that. Yes, for any query you can just put up into the comment box, my dear friend. Yes, but I think we can close today's session, and we have what we have seen: basic proportionality theorem. It's converse when an altitude or a median is there which is dividing the corresponding sides proportionally, then definitely those two triangles should be similar to each other, right? Like this. Okay. So thank you so much for watching, my dear friends. Let us wind up this session for today and be connected. Happy learning. Take care. Bye bye. See you. Right. But yes, don't hesitate to put up your queries and keep on practicing more and more questions. Okay, because in a 20 minutes or 30 minutes of session is very difficult to, and don't think that I'm just trying to help. Okay, but it's only you who can do it, right? So just proceed, do your efforts, put your efforts. Okay, let us go forward and you will succeed, my dear friend. And let me know where I can help you. I will try to, but yes, you are the baton holder. You need to go forward. Okay, you need to maintain the pace, keep on practicing, have patience, have some dedication, then definitely you will succeed, my dear friend. Okay, I am just a helper. I am trying to help you. Okay, but it's all you, all your efforts. which will pay off. Okay, so I'm there to help only, but you need to put your efforts, you need to practice more and more questions. Okay, then it will be definitely helping you to score good marks to succeed in your life. And thank you so much for being connected, and happy learning. Take care. Bye bye. See you, my dear friends, into the next class. Take care.